Now that we've reviewed the real numbers, we need to make sure you understand how to do the four basic operations: addition, subtraction, multiplication, and division. Let's take a look at three problems that I'm going to start you off on that you're going to be expected to finish in class. So first, a logical reasoning problem which states, formulate the following statement in terms of variables, then decide whether it is true or false. The opposite of the sum of two numbers is equal to the sum of the opposites of the numbers. If false, give a counterexample. If true, give two examples involving negative numbers. So it's important that we approach this problem and do it in the order that it's asking. So first we need to write it in terms of variables. So the opposite of the sum of two numbers. So we have two numbers. Let's call them x and y are our two numbers. So it says the opposite of the sum. So the opposite of the sum of the two numbers is going to be the opposite sign, negative, of the sum of the two numbers. That is the opposite of the sum of two numbers. And we're testing to see if it's equal to, question mark, if it's equal to the sum of the opposites of the numbers. So what that means is the opposite of each number added together. You are tasked with figuring out if this statement right here, is this always true? If it isn't true, give an example that makes it not true. And if it is true, give two examples involving negative numbers. The next two questions I'd like you to think about are, if you subtract a negative number from a positive number, the result is always a positive number. What you need to think about when you're attempting this problem right here is, what happens when you subtract a negative number? So think about that when you try to figure out if this statement is true or false. The next statement is, if you subtract a positive number from a negative number, the result is always a negative number. This is a little bit different than the first statement. Really center your attention on what it means to subtract a positive number, this time a positive number, from a negative number. It's a little bit different than the first statement. The next question I'd like you to think about is the following. You need to simplify this expression. As we've seen already, you need to follow PEMDAS. So first, we need to complete the operations inside the parentheses. So let's take a look at this one right here. You have negative 9 1/5 minus 9, meaning you're going to go down from negative 9 1/5. So the answer to that is going to be negative 18 and a fifth. The other parenthesis you need to attack is right here. You have mixed fractions with different bases, so you will need to get a common base, so work on the base of each so that you have a base in common, and then do the subtraction. After you do the subtraction, inside this set of parentheses, you have these brackets to deal with, so the multiplication of fractions, and then the multiplication of the constant on the outside. So make sure you come to class with an answer to this question as well. The last operation I want us to examine is division. And the division rule is defined as to divide a number a by a non-zero number b, so that's an important number, non-zero number b, multiply a by the reciprocal of b. To understand what this statement means, we really need to understand completely what it means for something to be the reciprocal of b. Simply put, the reciprocal of b is the number you multiply b by to get 1. So that's actually going to be 1 over b, because b times 1 over b is going to equal b over b, which is equal to 1. Another way to think of this is that finding the reciprocal is the same thing as flipping over the fraction. B is equal to b over 1, and if we were to flip that, you would end up with 1 over b. So there's two ways to think about reciprocals, but it's really important to remember that when you multiply a number by its reciprocal, you always get 1. So now that we know what a reciprocal is, you should be able to understand what it means for division here, which is that a divided by b means you are multiplying a by the reciprocal of b, which is right there, 1 divided by b. Another example with integers, you have negative 1 divided by 3, so you need the reciprocal of 3, which is right there, 1/3, because 3 times 1/3 is 1. We say that the result is the quotient of a and b. The quotient of a and b. The sign of a quotient behaves similarly to the sign of two numbers that are multiplied together. If you divide two negative numbers, you end up with a positive number. And if you divide a negative by a positive or a positive by a negative, you will get a negative number. So it's very similar to how things work with multiplication. Negatives cancel each other out, and a negative and a positive, the negative quote wins. Let's practice a couple division problems. Negative 87 divided by negative 3/5. Now the first thing you need to decide is where you want to put this negative sign. It can be either in front of the 3 or the 5. It's not going to matter. Traditionally, it usually gets tacked onto the top. So you can say that this is the same as negative 87 divided by negative 3/5. Remember that dividing is the same thing as multiplying by the reciprocal, so we need to find the reciprocal of negative 3/5. And we can do that by flipping it, and we get 5 over negative 3. So this is going to be the same as negative 87 times 5 over negative 3. Now we just need to multiply across on the fraction, and we will get negative 87 times 5 all over negative 3. We're dividing a negative by a negative, so we know our answer must be positive. The negatives cancel each other out. And the next thing we need to do is simplify. 87 divided by 3 is going to be 19. So you end up with 19 times 5, which is 50, because it's 5 times 10, plus 5 times 9 is 45, which is going to be 95. Here's another division problem. So first we'll flip what we're dividing into 42t over 14z, negative 14z. We also know that we're dividing a negative into a negative, so our answer must be positive. So we know that this is going to be equal to 42t over negative 14z times, and I like putting the parentheses around just to be clear, 7t over negative 6, because 7t over 6 is the reciprocal of negative 6 over 7t. We now have to do a little bit of simplification. We know we can cancel out the negatives because we have a negative times a negative, so we can make these positive. And then we can simplify the fraction. So we have 42, group it together, times 7. T times t is t squared over 14 times 6. Now we just have to figure out our common factors. 14 is the same thing as 7 times 2, and 6 is the same thing as 3 times 2. On the top, we know that 42 is the same thing as 6 times 7. And then we have the extra 7 and the t squared. So what cancels? First, you have a 7 and a 7 canceling out right there. And then you actually have, since you have 3 times 2, that's 6, that will cancel with that right there. So you're left with 7t squared all over 2. I hope you found this video helpful.